All right. So what'd you guys get for this one here? Yeah, square root of 36. It's multiplication inside, so that square root's like, oh, yay. I can just attack everybody. That's what I'm based on, is multiplication. Square root of 36 is 6. Half of G12 is G6. I like it. Do I need absolute value? If you put it, I wouldn't say bad, but the answer is already always going to be non-negative, right? So you don't have to put absolute value. It is a square root, so you have to be careful about it. It's an even root. They're uptight, so you got to be careful about it. But it's to a 6th power. It's always going to be positive or 0. Never going to be negative. Part B. Do part B the same exact way. And we did this when we did cubes. We were actually taking cube roots. Because it says split everything up into thirds. And that's exactly what we're doing. That's what a cube root does. Cube root of -8 we should know by now. Yeah, we've been doing that one for a while now. So it's -2. W to the fourth. And of course it's a cube root, so I don't have to worry. It's laid back. It can handle whatever. I like it, which is good because it's freaking negative inside. So this one is one I expect possibly some mistakes on. Just to save you from yourself, radicals cannot handle plus and minus. So if you leave it like this, you can't do shit to it. But you can rewrite this, of course, so you can do something to it. It can handle something inside that there's 2 of, right? So how do I rewrite this?
X minus 4 squared.
Yeah. So the question isn't what's the domain. The question is not what the domain is. The question is just simplify, right? So I rewrite this in a form that the square root can understand. And then, of course, this just becomes
X minus 4.
almost
Absolute value.
because x minus 4 could be negative, and it was an even root. We got to cover our ass for that, just in case. Yes.
So what if you tried to square that entire equation? So if you came up with x minus 2x plus 4.
Yeah, see, so you kind of stumbled here, right?
Mm-hmm.
But let me show you this. Is the square root of 25, is that equal to 7?
No.
All right. Even though 25 is 16 plus 9, and the square root of 16 is 4, and the square root of 9 is 3,
Yeah.
and that's 7. But I screwed up on this step right there. A square root cannot distribute across a plus because, or a minus, because they're not based on that. So yeah, you can't do the square root of this minus the square root. No, you're distributing it. It can't. You cannot distribute that. Why can you distribute something in front all day long? Because coefficients are based on addition, subtraction, so they work well with it. That idea of if it's based on it, it'll work well with it. That goes through a lot of mathematics. That will save you from that kind of mistake. You can't take a square root across minus plus because it's not based on minus plus. It's based on multiplication. That's why these were so easy, because it's multiplying inside. Do you guys see that? Okay. Do you like answering my questions? Okay. Let's see. So now we got part D. Oh, this one, we basically did this one earlier. I don't know if you remember. Yeah, it's just be 3 over 5, kick ass. And you can always check your work, by the way. I mean, if I think that's the cube root, then how do I check it? Well, I take this and cube it and multiply it by itself a couple times, right? 3/5 times 3/5 times 3/5. I could do the same thing with these. 6g6 times 6g6 is 36g12. It works. Hey, so it looks pretty good. You guys? Let's see, E. Yeah, what's the first step here? How do I rewrite this? Good. So it'll be 1 over
64
64 to 2/3. And what's the bottom become now? The what root? Careful. Cube root. Roots are on the bottom. You gotta love that shit. Right. So the cube root, 64 squared. I'm gonna put that, of course, on the outside because I know what the cube root of 64 is. 4. And of course, 4 squared. 16. Bam. So again, 64 is 4 times 4 times 4. Oh, there are 2. I want 2 of them, and I want to flip it. 116. Okay. Something like part F desperately has to be easy as hell. It just has to be. Because I know how to do like bases multiplying. I know what I do with the powers. And you got to know how to handle fractions. So I got A18, A56. What do I do with the powers? Yeah, LCD. Okay, has anybody ever told you this? What 8 times 6 is 48. That's not the LCD. What number do 8 and 6 have in common? What number do 8 and 6 have in common? 2. 48 divided by 2 is 24. That's the LCD. So if you multiply them and divide by what they have in common, you end up with the LCD. That's another nifty way to figure out an LCD. All right.
So we can use 24?
Yes, you should, because that's the LCD. So then you get a to the 3 over 24 times a to the 20 over 24 is a to the... Is that bigger or smaller than a? I love that question. Yeah, why is it smaller? It's 23/24 of an a multiplicatively, right? It's like 1/24 smaller than a full a. What would a full a be? A full a would be 24/24. This is 23/24. Just a little step down from whatever the hell a is. It's a little bit less. Sure, yeah, it's a B plus. A minus, right? I like that. Then here's my B's. G is B to the 5/4 over B to the 3/5. It's the same idea, right? Except now I subtract. And the LCD is obviously 20. So I get B to the 25/20ths minus 12/20ths. So I get B to the 13/20ths. Bam. If I wanted to write that in radical notation, what would it look like? Or, 13 on the inside. Normally with variables, again, we put it inside because it's more compact. With numbers, we put it outside so it's easier to do. I like it. Did you have to do that for this problem? No, but in the book, sometimes they'll say leave answer in radical notation or something, so you have to be able to change it back. Let's see, book. And then H. I love all you guys that skip this step. If you're not really sure, apply the idea directly before you do anything else. What do I mean by that? If I have a bunch of shit multiply being raised to a power, it's the very first thing I do. I take that power and distribute it to each thing. So it'll be 9 to that. It'll be x to the 4/3 to that. It'll be y to the 3/5 to that. And then each one of these is just a little bit easier to look at. Instead of trying to do it all at once in my head. What's 9 to the 1/2? 3. What happens here? No. So it'd be x to the 2/3 and y to the 3/10. I'm multiplying, so I don't need LCD. Multiplying is not as restrictive as adding. I don't need like terms when I multiply. Not exactly. Anybody, is there any questions on those? Do you guys get the idea? Yes?
For E, how would you get a 1 over 16?
Which step?
Well,
Are you cool with the first step, which is just applying the negative so it flips?
I didn't get, how would you get the 1 over 16, the answer?
No. So, I mean, if you understand this step, then it's impossible to not understand how I got 16, because
Oh, it's 4
that's 1 over 4 squared, yeah.
Oh, okay.
Okay. Okay.
I didn't see the
It's a
square.
question of being able to read my horrible writing. I understand. Yeah. I just want to make sure that everybody's got the normal ones, yeah.
So for H, you're multiplying, like the 4/3 and the 1/2 and then
Yes, and again, I know what to do here, right? Or you have to. Properties of powers, when I raise them in the power to a power, I multiply the powers. This is really just saying 5 groups of 3x's, which is multiplication. Doesn't matter. What is x to the b to the c? X to the bc, right? Some weird, funky, prehistoric math. I don't know. It doesn't give a shit what they are. What do I do to them? Multiply. Right? So I give a shit, because I'm the human here. I give a shit what they are, because then I have to actually do that. But what do I always do when I'm raising something with a power to a power? I'm multiplying the powers. These are fractions. Oh shit, I got to be careful. Reduce what I can, blah, blah, blah. But I know I'm going to multiply because that's the property. Doesn't matter what they are. Okay, cool. I like it.
And can you do the bonus question?
Yes, I will. I just want to make sure again. I love you guys. Any other questions about the normal, regular problems? Okay, so let's look at the bonus. Anybody try it out? What'd you get? No. But what'd you say? Yes. Cool. So look at it this way. If I cut a pie in half, and then I cut that in fourths, how many little pieces do I have now? If I cut a pie in half, and then cut each of those in fourths, how many little pieces do I have now? 8. 1. So like 1/8. 1/8 of a pie, right? So what was it again? It was 3, 2, 4. So 3, 2, 4, 1. So if you rewrite y to the 1/4, oops, got it. Y to the 1/4, what's the square root of something? It's to the square root of something becomes what power? 1/2 power. Cube root of something becomes what power? So cube root cuts things in thirds, a square root cuts things in half, a fourth root cuts things in fourth. So if I cut something in fourths, and then halves, and then thirds, I'm going to end up with 24ths. A little tiny sliver. Thank you so much. I need a little more than that. So y to the 1/24. Bam. So what's a shortcut? Multiply the roots. Multiply the indices. This is called the index of this root. I don't care about that word. I really don't. 3 times 2 times 4 is the 24th root. It's insane. And it's just because it's exactly because of that. It cuts it in that many pieces. So it's physical. You can imagine, you can see it happening. That's what a cube root does, cut it in pieces. So another root on top of it is going to cut it even smaller pieces. That's it. I like it. Okay. So let's see, the last thing for today. Yeah, cool. It's going to take a little bit to talk about. Let's see. So everybody got what they want from that bonus. Aw. There you go, little dude. So we got that bonus. There are actually a couple problems in the homework like this. So it was a bonus on the sheet, but now it's something you know how to do. Okay.
Does that always work when you like multiply the 3?
Yeah. So, I mean, give me your root. Fifth root of m. Give me another root. Fourth root of that. I mean, so that will be, so far, it would be the what root total? 20th root. If we cut something into 5 pieces and then cut each of those pieces into 4, of course I'm going to end up with 20 pieces, 20 slivers. So this will be 1/20th of what it started off as. You could have a fifth of the pie. No, I gotta chop that up because I got more people coming. So, holy crap. It's like a sampler. I don't know. Sorry, I'm hungry. Okay. $23 to Ben. I like it. Cool. If I put another one on top of that, it would just multiply by whatever that is. I like it. I like it. Okay. So, something I want to see if you picked up on this from earlier. This is a small thing, but it's kind of big to realize. What is the square root of 2 times the square root of 5? Can I do that? All right, got a lot of no's, but yes, I can because both of the roots are the same. So this is something we talked about earlier. I know it was a little bit quick, but as long as the roots are the same, we're allowed to put them together. Just to show you once, just once, why this is true. Maybe don't even write this down. Just absorb it as an idea of why it's true. I would never do this problem this way. But isn't this 2 to the 1/2? And isn't this 5 to the 1/2? That's amazing. And can't I see how the 1/2 was distributed? So can't I undistribute it? Factor it out in a way, right? And 2 times 5, of course, is 10, which is the square root of 10. So why would you do all that shit when you can just... They're the same roots, which means that they could then come out and just go over everybody. So you don't need 2 separate roots. You just need one big-ass root over what these are. 2 times 5. How are we doing there, is that? Now, I could do that backwards, too. I could start with rad 10 and write it as rad 2 times rad 5 if I needed to. That doesn't really make the most sense, right? So here's somewhere where it makes more sense. What about the square root of 50? Can you just do that directly? What's the square root of 50? Some weird number. A little bit bigger than what? 50 is a little bit bigger than this number. Yeah, a little bit bigger than 7. Because 49 would have been perfect, Jeff. What the shit is 50? But 50 has something in it that I can do the square root of. It's very similar to something I showed you earlier this semester, 8/3. 3 doesn't go into 8, but 3 goes into 6. So I split this up into a part I can do and a part I can't do. I do the part I can do. I don't do the part I can't do. We're about to do the same damn thing here. This is all based on addition and stuff. This is going to be based on multiplication. So instead of writing it in terms of something plus something else, I write it in terms of something times something else so the radical can actually do something because it's based on multiplication. So, of course, what does 50 have in it that I can do the square root of? 25. And then I can use this property in reverse. Square root of 25 times 2 is equal to square root of 25 times the square root of 2. What is the square root of 25? 5. What is the square root of 2? I don't know. Yeah. So it's sort of like reducing or rewriting a fraction, right? Sort of the same idea. It's the whole part and the extra part. It's the whole part and the extra part, right? Same exact idea. That 2 is extra, isn't it? If it only was 25, if it only is half of what I put up here, it would have been beautiful. So the little factor of 2 is extra shit. Oh, shit. The little, if only it would have been a 6. Well, I got a little extra 2. Shit, I got a little extra 2. Same idea. Okay. So what about this here? You think about it the exact same way, except now it's a cube root. Yeah, so you start thinking about 1, 8, 27, start thinking about cubes that will go into 24, and obviously 8 does. So I can rewrite this as the cube root of 8 times the cube root of 3. Cube root of 8 is 2. Cube root of 3 is, I don't know. Now let me show you an alternate way to do this that I don't prefer, but if you like it, you can do it, and I'll show you why I don't like it. I don't like it because you end up screwing yourself up. I'm trying to save you from that. So that's the problem we just did. I could instead do this always. Just start to break this down into its prime factors. So 2 times 12, 2 times 6, 2 times 3. There we go. They're the prime factors. What is a cube root looking for? Groups of 3. What do I see a group of 3 of? 2. What I get is the wrong answer. I get this shit. What have I done wrong? That is wrong. Don't write that. Don't write that. What have I done wrong? Yeah, the 3 and the 2 in the wrong freaking place. See, that could never happen doing it this way. I see where the 2 came from. The cube root of 8 is 2. The cube root of 3, I don't freaking know. Over there, it's a little bit more loose. Where's the 3 go? Where's the 2? Hopefully it makes sense. I got 3 2s. That's the one that should be able to be written out front. I only had one little 3 dude. He's stuck inside. I have a colleague that teaches this, like, if it's a cube root, it's a little bit stronger prison. So you need 3 people to be able to break one of you out, and the other 2, I guess, die on the way. It's a little bit gruesome, but oh well. This poor dude over here only had one of them, Sally. I guess I'm stuck. And this guy got scot-free, and the other 2 2s, dead. So I don't know if you like that. I don't personally like that too much. If you have no opinion about that, I understand. Okay. So actually, on the back of this sheet, I mean, there's really not much more I could say about that little piece here. On the back of the sheet, I've got method 1, which is a slightly preferred way. I'm not going to give you more points if you do it this way. And then method 2, I did the same problems and showed you what it looks like if you do the prime factorization versus just breaking it up into a part you can do and a part you can't do. Now, real quick, I always get this question, why didn't I do 4 and 6? Because that's 24. Why didn't you do 4 and 6? Because I can't do 4 or 6 cube root. So, of course, I'm going to break it up in the way where I get a part I can do and a part that I can't. If I can't do that, then the problem is not doable. I can't simplify it. That's all. Okay. So if I do another one, let's see, real quick, before I unleash you on these problems. What about, what you got, John? The square root of 98. Yeah. So again, it's even, so you can think, well, let me try to split up as 2 times something, and it's 2 times 49, and what's nice about 49? Yeah. So the square root of 98 is the square root of 49 to the square root of 2. Square root of 49 is 7. Square root of 2 is, I don't know. So it is exactly like mixed numbers. It's a whole number and then the leftover, the not quite full number. Square root of 2 is not quite a full number. Poor little dude. So go ahead and try out the bottom of this back page here, simplifying radicals. There's 10 problems down there. Go ahead and try those out. The first one I already did for you. Isn't that nice?